welcome to our day 22. So today we are going to learn about a very powerful library in Python, which is NumPy. Right, so NumPy, it's a shortcut for numerical Python. So as the word suggests, it is meant for numerical computations, doing some hardcore calculations. It is meant for its speed. So let's see how powerful NumPy is. Right, so compared to some built-in functions as well. Right, so first of all, so NumPy, you have to import it. We've already learned about modules in our earlier days. Let's import NumPy. So the way you import, I'll just zoom it for you. Import NumPy as np. So we have our NumPy, which is loaded now. So NumPy, you can compare it with a list, right? You can create an array, right? So for example, let's say numpy.array, and let's give a small set of numbers 1 2 3 4 and 5, and once you run this, so you see that it's more like a list itself, like Python lists, right? So yes, you can declare this, like for example, you can give it a name, right? So arr equals to array, and this becomes your NumPy array. Now, not only this, not just declaring this, of course, you can do some operations as well. Like for example, let's say I want to like add a couple of arrays, right? So I have array 1, array 2, I want to add these two arrays. So let's see how we can do that also. Like I have an array 1, instead of typing everything again, you can just copy this above one, just paste it here, right? So let's reduce it to, let's say 1 2 3, okay? And once again, let's copy this. Let's create one more array. This, let's call it 3 4 and 5, okay? Or you can say, okay, I'm sorry, 4 5 6, right? So I have two arrays. Now what you can do is just simply arr plus arr1 plus arr2 should give you addition of each of these values. So 1 plus 4, 2 plus 5, 3 plus 6, right? Which is amazing, as you can see, right? So you can straight away add these two arrays. Now you can do other operations, like I want to slice it, or I want to index, I want to get the first element. You can do all of those things, right? So let's see how you can do those things also. Like for example, let's paste it. Now let's call this array and 4 5 6. Let's run this. And if you want the first element, so just like we did for the list, array of 0 gives you the first element, right? As you can see, it gives you the first element. Array of -1 gives you the last element. Yes, as you can clearly see, if you do -2, it will give you, so negative indexing works, even the positive indexing also works. And if you want to slice it, so meaning, so you want, let's say 0 to 2, that means you get 0th and first element. And if you do 3, you can get this also, right? So you will be able to slice these elements as well. Right, now coming back, right? So these are, this is also something that we have done in lists. And here in NumPy, what it allows is, like I'm sure you would have studied about matrices in your school or college, right? You can create those matrices as well. Like it's not just one dimensional array, but you can create a 2-dimensional array as well. Like for example, so I have the same array, right? So 1 2 3 4 5 6. Now you can reshape it, right? So if you want to get the correct, the current shape of it, so let's do arr dot shape, and let's print this, and you see you get the shape of the array, right? So that means it has 6 comma 1 kind of. If it's not, if there's no element, then it's 1, right? Now you can reshape it. For example, arr dot reshape, you can reshape it to, let's say 2 by 3, okay? Now let's do that. Now you can actually see it is reshaped to not just a single line, right? So a single row. Now you have couple of rows and 3 columns. So that way in your existing arrays, it is very easy to reshape your arrays as well. So this makes it easy. So that's why NumPy is used to actually read images as well, because images are nothing but what? RGB values, right? So if you have a 1000 by 1000 pixel image, it is nothing but each pixel has a value of RGB, right? So that is why NumPy is capable of reading those matrices. That's why it makes it powerful to read images as well. And another important feature in NumPy is actually something called broadcasting, right? I'll tell you what this broadcasting is, right? Now, okay, let's get back to our array. So we have our simple array. Now let's say if I want to add 1 to each of these elements, right? Now how do I do that? I can add, like, I can write a for loop, or I can do something like a list comprehension, all of that. But in NumPy arrays, it is as simple as ARR plus 1, and run this. This will automatically add 1 to every single value, and it's quite fast, right? Isn't it amazing? Right? So once again, so this feature is called broadcasting, where it applies to each and every single element in this NumPy array. And so what is the use of this broadcasting, right? So this broadcasting is used in all kinds of matrix operations, like for example dot product, right? So dot product, I'll show you what dot product is, right? So you don't have to break your head to learn what is this dot product. Now for example, I just have two matrices, M1 is equals to NumPy. Oh, so my auto code is already giving me all the values that I need, right? So okay, so let's consider its values. So NumPy array, and yes, what do we give, right? So let's give 1, 2, and then let's also give 3, 4, very simple, and then M2. Yes, let's take these values. So how do we take these values? Use control key and right arrow, so it automatically fills up these values. So okay, you have matrix 1 with elements 1, 2, 3, 4. You have matrix 2 with elements 5, 6, 7, 8. So assume it like a square. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you have M1 comma M2. Now you can do a dot product of M1 and M2 in just one line. How do we do that? NP dot of M1 comma M2, and run this. You automatically get your dot product values as well, right? So that's how simple. How do we get these numbers? 19, it's quite simple, right? So you have 1 into 5 plus 2 into 7. So 1 into 5, 2 into 7. So you just have to assume these numbers to be, as I said, right? So 1, 2, 3, 4 and 5, 6, 7, 8. So you multiply so 1 into 5 plus 2 into 7, that gives you 19. So 14 plus 5, and then 1 into 6 plus 2 into 8. So 6 plus 18. 2, 8, 16, and 1 into 6, right? So that gives 16 plus 6, that is 22, right? So that's how you can compute dot products as well. So not just, I mean, small elements, you can take matrices of 10 by 10, 40 by 40, 600 by 600. So this computation is quite fast. And of course you can also do some simple statistical calculations as well, like let's say NumPy dot mean of let's say our ARR array, right? So this gives you 3.5, so which is our array of 2, 3, 4, 5, 6, 7, and yes, this is our array 1, 2, 3, 4, 5, 6. Let's look at our array once again. Yes, this one. And yes, you can also do things like np dot standard deviation. What is the standard deviation of this? And you will be able to get standard deviation as well, right? And more powerful things of NumPy, you can also generate random numbers, like for example NumPy dot random dot rand of, let's say, a 5, right? So it gives you 5 random numbers between 0 and 1. You can also generate random int. You can also generate like choose random element between two things, right? So this one is a simple, right? So if you put 10 here, you'll get 10 such numbers between 0 to 1. right? And if you have some missing data, for example, I have an array which also has 1 2 3 comma, let's say we don't have 4, and you have nan value which is not a number, and then you have 5, and then you have 6. Okay, so you have this simple array. If you try to print this array, it will tell you that it has a nan, okay, not a number value. Now if I want to, so in this case there's only one nan, you can even replace it manually also, but in case of hundreds of elements, sometimes you can't even count it visibly, right? So in those cases, what you can do is np dot if it's is nan function allows you to fill up the, or find out where exactly the nan value is. You just run this, it will give you either true or false, right? So based on that, you can fill up nan values, you can remove them, or you can identify exactly where is the nan value. You can see automatically it gave us true in the 4th position, so where there is a nan value. Now, okay, so David, you mentioned that these are very powerful. Can you show me how powerful these are, right? So before we close, one last thing, as I said, let's look at how good is it compared to a simple list, right? So Python already has lists, right? Now how different is it compared to Python list, right? So list versus NumPy array, let's do a comparison. So how do we do it? We can just import a time module to identify how much time is it taking. Now let us say we want to generate some 1 to 1000 numbers. How do we do that? List of range. So we talked about range when we were learning about for loop. So let's say I put a range of 10. So what happens? You get 10 values. Okay, now let's give it a name, ls1. Okay, and now if I do a sum of this ls1, okay, you get the value, right? Now let us see how much time is it taking to calculate this sum. So let's do a start is nothing but time.time, and then let us compute this sum, and end is equals to time.time, and yes, as our bot is suggesting, and print end minus start. Let's run this and see how much time is it taking. Okay, it's taking, right, so like 10 power minus 5, right? So very small time. Let's increase it. Let's increase the values. Let's add few more zeros. Now you see it is taking quite a long time, right? So let's add one more 0 and see how much time is it taking. So the time you are seeing is actually in seconds, so it has taken quite a long time, so 0.8 seconds. Now let us do the same computation in using NumPy array, right? So you have a list and we are just doing a sum of this list, right? So let's copy this exact same snippet and paste it down below. So instead of doing a normal sum, so let us do numpy.sum of array, and now let us try to run this one here, and let's look at how much time is NumPy actually taking. All right, look at this. Okay, so David, what happened here? So just a second. So I've missed to convert it into a NumPy array. So let us add that piece. So my ls1 becomes numpy.array, because in NumPy you can only do computations on NumPy arrays, right? It's not the list. Now let us try to run this again. And okay, so it takes time to generate. Now look at this difference, right? So you can almost see the visible difference. Let's run each of them once again. Let us run the list again. Let us run the NumPy again. And yes, it took 1.13 seconds this time to just compute the sum, and 0.07. So it's almost like half, right? So that is how NumPy is so powerful in any kind of computations, right? So yes, that's all for this module. See you in the next one.